All right, hi everyone. Welcome to yet another lecture in the mathematical methods course. All right, in this lecture, in the previous one we talked about discrete random variables, probability distributions, and some stuff around that. Okay, we got into really the basics. We're just gonna get into a bit more depth. Test the waters a little bit more, and we just gradually getting deeper and deeper until we're comfortable. All right, with all sorts of depths. So let's just start off by looking at the mode and the median. Okay, so you've probably heard of these before: mean, median, mode. Okay, so stuff like that. Simple stuff. Okay, it's kind of elementary in statistics, and really, a mode is just the most frequently occurring value. Okay, so most frequently occurring value. Okay, so if you have a string of outcomes, you get 1, 2, 2, 5, 2, 5, 2, 5, and you just get a lot of different outcomes. So the most frequently occurring one is your mode. Okay, it's pretty simple and straightforward. When you look at probabilities, so if you roll some sort of unfair dice where the probabilities are changed, then the most likely outcome, or the one with the highest probability, okay, that is the mode, okay, because since it has the highest probability, it's gonna come up more often, okay. Mode, simple, straightforward. Now the median, it's a bit trickier compared to the mode. It's trickier because it's not as simple of an approach. There's a few more steps, but once you get used to it, it seems simple and straightforward. Okay, so let's start off by defining what it would be like. It is the 50th percentile. I will just write that as the number 50th percentile. Okay, so the median is the 50th percentile. Now, how do you find that? So, if you have done median before, you would remember that if you have a bunch of numbers like this, you have 1, and then you have 5, 4, okay, oops, wrong pen. 1, 5, then you have 3, 4, and 2 and 6. Okay, so to find the median among them, first of all, you would sort them. Okay, that will give you 1, 2, 3, 4, 5, and 6, and then you find the middle value. Okay, which is 3.5. Middle value, hence median. Okay, that is where the median comes from. And that is your process of finding a median normally. Okay, but now, since you have probabilities as well, that's going to come in play. First of all, the first step is the same. Sort them. So sort your possible outcomes. If it's a roll of a unfair dice, for example, you have these outcomes and you have their probabilities, okay? Which is, let's say 0.1, 0.1, 0.2, 0.2, 0.3, 0.3. Just for ease of access, I think it's incorrectly done. So let me just have a quick look at that. Yeah, that should be a 0.1 as well. Okay, so you'll see why I did that later. But for now, we have this, and what we are going to try and do is find, instead of finding a middle value now, we're going to find when sum of probabilities equals I don't know why the pen is acting a bit funky. Probabilities equals 0.5. Okay, that is the goal, and that is how you would find the what you call it, the 50th percentile. Okay, and literally how you do that is you just go p of 1 is equal to 0.1, p of 2 is equal to 0.2. Oh, sorry, p of 1 is equal to 0.1, and then 2 is plus p of 2 is equal to 0.1 plus 0.1, so 0.2. Okay, and then p of 1 plus p of 2 plus p of 3 is equal to 0.1, oh, sorry, 0.1 plus 0.1 plus 0.2, which gives you 0.4, and then all of that plus p of probability of getting a 4 is equal to 0.6. And now we see that 0.6 is greater than 0.5, therefore 4 is the median. Okay, and you literally just do that. You find the probabilities for each of the outcomes, and as soon as the sum of the probabilities is equal to or greater than 0.5, that's your median value. Okay, so it is a bit of a process, and that is why we're going to do a quick example just to get familiar with it. And once we are familiar, I mean, there's really not much more to do with this. Okay, we're just gonna move on to something else because it's not really that hard of a concept. Okay, so we have a magazine store that is selling magazines. Okay, and it says that the number of customers are being recorded. The amount of magazines purchased by customers is being recorded. 25% of them purchased only one magazine, 38% purchased two, 21% purchased three, 13% purchased four, and 5% purchased five. Okay, a lot of information, but we can we'll look through it later. Just continue with the question. Let X be the number of magazines sold to a randomly selected customer. Okay, so one thing at a time. It is asking us to state the possible values of X. Well, X being the number of magazines. Some people buy one, some people buy two, some people buy three, some people buy four, some people buy five. It doesn't mention 0 magazines bought or 6, 7 magazines bought. So it's only from 1, 2, 3, 4, and 5. Okay? Now we're going to construct a probability table for X, okay, which we have looked at before. All right, let's just quickly do that. So we have X is as the possible values. Okay, so it gives 1, 2, 3, 4, and 5. And the probability that X, a randomly chosen customer, gets 1 is 0.23. Try and write it as decimals. It is easier that way. You will make less mistakes instead of writing it as a percentage. And you literally just dot the points. Okay? Very simple. All right. And C, graph the probability distribution. Now, we have not looked at that yet. Okay? But that is fine. To graph it, you essentially make a bar chart of this form. Okay? Where each of the points on the x-axis or the horizontal axis represents the possible outcome, and then the y-axis value or the vertical axis value shows the probability of that outcome. So you have 0.23 and then 0.38 and then 0.21 and then 0.13 and then 0.05. Okay? And obviously, you would draw it a bit more accurately, but for this time period, I'm just trying to show what it looked like, what the process is, and that is how you would do it. Okay, so you have a 0.23, okay, and sorry, I should probably write that a bit better. Okay, so let me just go to 3. Okay, this has 0.21. This has blah blah blah. Okay, so it is pretty straightforward to draw a histogram or a graph. Nothing that complicated. You just get your values and plot it to raise the bar up to their probabilities. Now, here is the thing that we are interested, which is the mode and the median. Okay, so the mode, we remember, is either the most frequently occurring value or the most likely outcome. Okay, we don't know what the most occurring is, but we know what the most likely is. They do point to the same thing, but I'm just saying as in we know the probabilities, so we can find out the most likely one, which seems to be 2 magazines. So the mode is 2 magazines. Okay, you can say x is equal to 2. Median. Okay, so again, we're going to sort it in ascending order, already done. Okay, and then we're going to find out when the probability equals to when the sum of the probabilities equals to 0.5. Okay, so let's just go ahead and really quickly do that. P1 is equal to 0.23. P2, sorry, keeps making that mistake, but that is okay. P1 plus P2 is equal to 0.23 plus 0.38. And would you look at that? We already have something that's greater than 0.5. Therefore, 2 is the median. Okay, so we have found when the probability, sum of the probabilities, is greater than 0.5, and that gave us a median. So just like that, you can very quickly find the mode and the median. But obviously, as your points increase, like if you have more and more possibilities, it gets a bit harder. Okay, well, not harder. It just gets a longer process. So it is simple, but it can potentially take some time. However, in the exam or any test, I can guarantee you there would not be more than 6, 7 points. Okay, so it's not that much of work, but it still takes some time, but it's not a very hard thing. And as you get more practice in, it will become faster as well. All right. So there we go. All right. We have done mode and median. Let's move on to a familiar face. Okay, the probability distribution. Now, if you remember, the probability distribution is just showing that we know all the outcomes and we know each of the probabilities. Okay, there are multiple ways to show it. We looked at a table, we looked at a graph. We're going to later look at one more. But there are some rules to it. There are some sets of criteria that the distribution has to meet to be a valid probability distribution. Okay, so the first rule is something we've already looked at, that the sum of probabilities equals to 1. Okay, we've already looked at that. All right, and that is precisely why I made this a 0.1 instead of a 0.3, because that is now 0.1 plus 0.1, 0.2 plus 0.2, 0.4 plus 0.2, 0.6 plus 0.3, 0.9, and then plus 0.1, 1. Okay, so that is the first rule for it to be a valid probability distribution. And the second rule is that every probability is less than 1. Okay, there is less than equal to 1, sorry. And every probability is greater than equal to 0. Okay, it kind of makes sense. Like 0 is basically it can never happen. How can it doesn't make sense to have something less than that. What does that probability mean? And 1 means it's guaranteed to happen. What does anything above 1 mean? Therefore, it has to be between 0 and 1. Okay, so that is our rules. As promised, we are now going to look at another way of showing a probability distribution, which is through a function. Okay, it's not as complicated as we've looked at functions before. It's just, you can say, for example, you have, I'm just going to write that down, P of, shown as a function. Okay, so for example, you have the function P of x, okay, where P of x is simply this. Okay, this is what we saw in the table, all right, that a randomly chosen value equals a particular x. Okay, so that is what the P of x means. P of x can be shown as a function. So for example, we have this function, okay, for x equals 1, 2, 3, and 4. Okay, now what this means, we'll get into it really quickly. All right, so what this means is the probability of getting a 1 is not written. We just have to calculate it, and it's 1 plus 1 over 34, 2 over 34. Okay, probability of getting a 2 is 4 plus 1 over 34, 5 over 34. And then on you go. Okay, mainly what you're going to be doing with probability distributions and probability functions in general for now is you're just going to see if they're valid, find their mean, find their mode, and use that to find certain probabilities, such as what's the probability that you get a 1? What's the probability that you get a 1 or a 2? What's the probability that you get something that's 2 or less than 2? So stuff like that, and really it's mostly intuitive, but sometimes it does get a bit tricky, which is why we're going to look at a lot of worked examples that are going to be handpicked and going to cover every possible scenario. Okay, so please make sure to tune into that, and I'll leave you with that for now. Thank you.